don't have to use even a financial calculator for that matter. It's very simple. Okay, and let's look at this concept of effective annual rate. Now, why this concept is important? Because in the market, you have many products. Okay, not only banking products such as fixed deposits and whatnot. You also have this unit trust, and you have many other banking products where you need to make comparison, because sometimes the compounding period is not the same. Okay, so you have to actually calculate the effective rate, okay, due to the difference in the frequency of compounding in a year. Okay, so that's why we have to calculate what the so-called effective annual rate. Okay, now the formula is simple. Okay, this is the formula. Okay, effective annual rate is actually 1 plus j divided by m to the power of m all together minus 1. Okay, so it is not to the power of m minus 1, yeah? It is to the power of m. Solve that one first, then only you minus 1. Okay, now is this j and m now alien to you? No. Okay, because it's the same j, which is the nominal interest rate, or the stated interest rate, and m is still our frequency of compounding in a year. Okay, it can be annual, semi-annual, quarterly, or monthly. Okay, so let's look at this example. Now, this bank charges interest at 5%, compounded semi-annually. Okay, so let's say you read the brochure, you read the website. Okay, we charge 5% only. Okay, but with semi-annual compounding, the effective annual rate is actually 5.6%. Okay, not 5%. 5% is the nominal or the stated interest rate. Okay, how do we get 5.6%? Okay, applying the effective annual rate formula, it is 1 plus j divided by m. Remember, m is 2 because of semi-annual compounding, and to the power of m, so to the power of 2, all together minus 1. So you get 5.6%. Okay, let's move on. Another example. Calculate the effective annual rate of a loan that charges 1.5% per month. Is there a loan that charges 1.5% per month? Seems familiar, right? Yes. Credit card. Okay, it is the credit card. Okay, 1.5% per month. And they claim that 1.5% times 12 is 18% per month. Is it really true 18% per month? Let's calculate. So 1.015, because this is the monthly, already the monthly 1.5%. So 0.015 plus 1 is 1.015 to the power of 12, because monthly compounding, m is 12. Altogether minus 1 becomes 0.1956 or 19.56%. So effectively you are paying 19.56% per year. This is the effective annual rate. Compare this with the 18% is already high. Okay, but effectively you are paying 19.56% interest per year on your credit card. Okay, let's look at another example. An investment account effective annual rate is 12%. This is the effective annual rate. Already the EAR solved for you, given for you EAR. Now you are going to find what is the nominal rate if it is compounded quarterly. Okay, so this is another angle or another perspective. Okay, given an EAR of 12%, find the nominal interest rate. Okay, and the compounding frequency is 4 times a year, or quarterly compounding. Okay, so now you have to rearrange. Simple, use mathematics. EAR is given, so you are trying now to find your J. Okay, so what you need to do is put your 1 plus J to the power, divide by M to the power of M on the left hand side, and EAR, now it becomes plus 1. Why? Because when EAR jumps to the right hand side, okay, it becomes plus 1 here. Okay, so what you need to do is apply the algebra that we have seen earlier to solve for M. So in this case, right, j to divide by m equals to AAR plus 1, okay, to the power of 1 over m minus 1, okay, and remember m, okay, is quarterly compounding, so m is 4, so you can easily solve for j. So in this case, j over 4 is equals to 1.12 to the power of 1 over 4 minus 1, so j over 4 equals to 0.028, and j is equals to this term here, okay, multiply by 4, so it's 11.449%. Okay, so this one is another angle, okay, which is the nominal interest rate of 11.49%, okay, at quarterly compounding is effectively 12%, okay, per year. Okay. Now this nominal or stated rate, sometimes that's why it is also called the annual percentage rate or APR, which you sometimes see, okay, in the banking products, right? Now, before we move on, okay, notice that up to this point, our frequency of compounding, okay, is defined in such a way that they are either annually, okay, semi-annually, quarterly, or monthly. Now, can interest be compounded more frequently than that? Yes, you can actually do that. Okay, to what extent? Can you compound it weekly? Yes. Can you compound it daily, for that matter? Yes. Let's look at this concept of continuous compounding. Okay, where continuous means it is more frequently than daily actually. It is continuous, okay, or effectively non-stop. What does it mean? Okay, let's look at this table to understand it better. Now this table shows the various future values of 1,000 at 5% interest rate after 5 years, but at different compounding frequency. Okay, so the principal, okay, is the same, 1,000, okay, at interest of 5%, time period is 5 years, okay, throughout. Now the difference is only this frequency of compounding in a year, which I call FOCIAY, okay, frequency of compounding in a year, which is your M in the formula. Okay, so it can be 1, 2, 4, okay, 1 for annual, 2 for semi-annual, 4 for quarterly, 12 for monthly, and 365 is for the daily compounding. Okay, just for example sake. Now the future value for annual compounding is 1276.28. For semi-annual is 1280. For quarterly it's 1282. For monthly is 1283, and finally for daily is 1284. Now, of course, the more frequently, okay, interest is compounded, the higher would be the future value. Okay, all right. But notice that it increases, but at a reducing marginal increment, right? And if you look at the daily, it's 1284, which is an increase of about how many cents compared to 1283.36. Now, in this case, okay, interest can also be compounded more frequently for this matter, such as every hour, every minute, or every second. Thus, the term continuous compounding. Okay? Now, if it is compounded continuously, okay, then the I and the N in the formula actually cannot be divided by the regular M, okay, your frequency of compounding earlier, because it is a very large number. So in this case, a simple formula which uses the natural log function is used as follows. Okay, Fv equals to P times E to the power of J times T. Okay, what is E? Okay, E is the continuous compounding function. Okay, it is available in your calculator. Okay, so in this case, to find the present value, you simply find the reciprocal, okay, of the formula, which is future value divided by E to the power of J times T, which essentially equals to Fv times E to the power of, remember reciprocal, negative J times T. Let's look at an example. What is the future value of 1,000 after 5 years if interest rate is 5%, compounded continuously. Okay, so applying the formula, the future value now becomes 1000 times, remember your e to the power of 5 times 0.05. Okay, so 5 times 0.05 is 0.25. So what you need to do is, in your calculator, is 1000 multiplied by, okay, you press the e function in your calculator. Okay, you can find it in the manual, or you can check the YouTube how to use a calculator. Okay, so e to the power of 0.25 then multiplied by 1000 gives you 1284.03. Okay, another example is, how much should you deposit today in an account that pays interest rate of 7.5% compounded continuously so that your savings will be 10,000 in 7 years. This is the present value. Okay, present value scenario where solving for PV, now PV becomes 10,000 times E, but there is a negative here because of reciprocal. Okay, so negative 7 times 0.075. You have to calculate this first before you press the E function and multiply by 10,000. It becomes 5915.55. You can actually also calculate the effective annual rate for continuous compounding, which is given as this formula as follows. Okay, EAR, the effective annual rate, now becomes e to the power of j altogether minus 1. It's not that difficult. You just have to know how to use your calculator. So calculate the EAR of a loan that charges an interest of 18% compounded continuously. So applying this formula, okay, EAR now becomes e to the power of, what is your j? 18%. Okay, altogether minus 1 equals to 19.72%. This is the credit card scenario just now. Okay, 19.72%. So that's the end of part 1 for our time value of money lecture, step-by-step approach. I hope you can benefit from this and you can understand this, and I see you soon in part 2, second part for the time value of money.